Day 2 of organic chemistry brings us to functional groups. Functional groups are something other than an H attached to that chain of carbons, something perhaps more functional. The first functional group we're going to look at are alcohols. Alcohols are what's called a hydroxyl group attached to the carbon chain. And a hydroxyl group is an OH. Anytime you see an OH in organic chemistry, it represents an alcohol. When we name alcohols, we attach the ending OL. Here's an example. You can notice our OH on the end of our hydrocarbon chain. Again, if we're going to number this, we'd say 1, 2, 3 carbons. So our prefix for 3 carbons is prop. We're going to change the ending to OL to indicate that we have this alcohol on it. Similar to our double and triple bonds, we need to add a number to make sure we are correctly stating where that alcohol is. And our rules still apply. So although if I number it from left to right, I'd call it 3 propanol. If I number it back the other way, it should be 1 propanol, and 1 is lower than 3, so the green way is the correct way to number this particular chain. 1 propanol. Again, prop tells us that there are 3 carbons. ANE would tell us that they're all single bonds. The OL at the end tells us there's an alcohol, which is an OH, and the 1 tells us it's on the first carbon. And if we take a look, 1, 2, 3 carbons with an alcohol, but this time that alcohol is on the second carbon. So we would call this one 2 propanol. Again, A and L tells us, or AN tells us they're all single bonds. The OL tells us there's an alcohol, and there that is. It's on the second carbon, which again is different than 1 propanol, which goes to show why the numbers are important. Sometimes you have multiple functional groups. When this is the case, you'll use these prefixes, 2 for di and 3 for tri. If you ever had 4, you'd use the prefix tetra, but I don't think you're going to see that very often. So here's an example. Again, we count our initial carbon chain. 1, 2, 3, 4, 5. So now we're working with a pent chain. There's 2 alcohols. They happen to be on the second and the fourth carbons. So we're going to call that 2,4-pentadiol. Again, where are all these coming from? The pent tells us that there are 5 carbons in the parent chain. The A here is going to let us know that they're all single bonds. The OL lets us know that there's an alcohol. And the di tells us that there are 2 of those alcohols. So 1 right here and 1 right there. The 2,4 are letting us know, hey, those alcohols, those 2 alcohols are on the second and fourth carbons respectively. Our second functional group is what's called a carboxylic acid. A carboxylic acid is a carboxyl group, which, as you can see, is a carbon, which is double bonded to 1 oxygen and single bonded to a hydroxyl group, similar to an alcohol. But watch that double bonded oxygen, that makes it a carboxyl group instead of an alcohol. So watch out for that. To name carboxylic acids, we add the ending oic acid to the end of our chain. Make a quick note that due to the structure, this one carbon, double bonded to oxygen, single bonded to our hydroxyl group, that's all 4 bonds carbon can make, which means carboxyl groups must go on the end of a chain, and therefore we don't have to number them. They're always going to have to be 1 carboxyl. So here's an example. Just 1 carbon. You'll notice he's not even attached to another carbon. Our prefix for 1 carbon is meth. We say the A and E, methanoic acid. Again, the oic acid lets us know that we have a carboxyl group, which is a double bonded O, and a hydroxyl group, both on the same carbon. Here's another one. Again, if we count our carbons, 1, 2, 3, 4. We know that our prefix for 4 is bute. We notice on the end here, we have our carboxyl group, so we have a carboxylic acid. So we would call this one butanoic acid. Again, bute for 4 carbons, oic acid, telling us that we have this structure here at the end. Now, just because we don't need numbers doesn't mean we can't have multiple carboxylic acids. So here's an example. Again, we should identify right from the get-go. We have a carboxylic acid here on this end. And then another one here on the other end. That's interesting. But given our knowledge of naming, we should be able to figure this one out. And let's count the carbons. 1, 2, 3 total carbons. So we know our prefix for 3 carbons is prop. We know that it should have an oic acid ending as well. Remember from the previous slide that whenever we have 2 of something, we use the prefix di. So we'll slide that di in before the oic acid. So there that is. Propa, telling us that there are 3 total carbons. Propanadioic acid, telling us that there are 2, di means 2, oic acids.